So in this chapter, in chapter 6 of network layer, I'm gonna discuss the summary of chapter 6. So we have first network layer. So network layer is a service of one end device can communicate with applications and servers running on another device. So So the protocols of the OSI models network layer specify addressings, the process, and enable the transport layer data to package and transported the network's encapsulations. Enable data to pass to a destination with a network or another network with minimum overhead. So this chapter is focuses on the role of the network layer. So it examines how a device networks flow and the data packets within a network. It also covers how communication between networks is facilitated. So first, we have network layers of layer 3. Provide servers to allows end device to exchange data across the networks. To accomplish this end-to-end point transport, the layer use four basics process. So the four basics process we have addressing end device. So we have addressing end device and encapsulation and routing and the encapsulation. So first, what is addressing end device? So end device must be configured with an unique IP address of identifications of the network. So encapsulation, the network layer encapsulate the protocols of data unit of PDU. So from the transport layer into packet, the encapsulations process adds IP headers information such as IP address of the source sending and destination receivers. So the third way we have a routing. The network layer provides service to the direct packets of destinations. So hosts on another network to travel to the other networks. The packet must be processed by a router. So we have the encapsulation. So when the packet arrives, so the network layer of the destination host checks the IP headers of the packet. If the destination address within had a header matches its own IP address, the IP address is removed from the packets and the packet discapsulated by the network layer. So first we have a characteristics of IP. So characteristic of IP's designs is a protocols with a low overheads. It provides only the functions that necessary to provide to deliver a package from source to destinations over the in connected systems of networks. So the protocols was not designed to track and manage the flow of packets. So this function is required and performed by another protocols of other layers, primarily TCP and layer 4. So the characteristics of IP, we have the first is connectionless. So connectionless, no connections with the destination is established before sending the data packets. So we have the best efforts. So best efforts is inherently and unreliable because best efforts packets delivers is not guaranteed. Best efforts, but it's not guaranteed. So media independence, uh, operations independent of medium such as copper, fiber optics, wireless, and carrying data. So we have the IP connectionless. So IP connectionless meaning that no dedicated end-to-end connections is created before data sends. So connectionless communication is conceptually similar to sending letters to someone without notifying the recipient in advance. So connectionless data communication work on the same principles. So information established as end-to-end connections before packets are forwarded. An IP also does not require additional fields in the headers to maintain established connections. So the process is greatly reduce the overhead of IP. However, with no pre-establishes in end-to-end connections. The senders uh, are unaware whether the destination device represents functional, or when sending packets are they aware if the destinations receive the packet. So we have the best effort delivery. So best effort delivery is unreliable, means that IP does not guarantee or capability to manage the recover from the undelivered or corrupt packet. So that is for best effort delivery. Best efforts but not guarantee. So IP media independence. So IP media independence is independently of media that carry data is lower layers of protocols. So like I said, it uses like a data carrying of coppers, fiber optics, wireless. So it's a signals over fibers or wireless radio signals. So it's on the IP media independent. So we have IPv4. So IPv4 is a version contains 4-bit binary set of 10100 that identify this as IP version of 4 packets. It's like in the our version of our cell phone, we see a 4-bit binary of versions of our phone. So differentiated service of DS, formerly called type of service DOS field. The DS field is a 8-bit field used to determine the priority of packets. 6 most significant bits fields is the differentiated service code point, and the last 2 bits is explicit congestion notifications bits. So time to live. So contains 8-bit binary value that used to limit the lifetime of packets that packet sender sends the initial TTL. Value and then decrease by 1 each time 0 packet processed by routers. If the TTL field decrements up to 0, so the router discards packet sends internet control, manage protocols, time exceeded message source of IP address. So protocols, we have a protocols with identify next level protocols. This is 8-bit binary, indicates the payload type of packets is carrying, which enable the network layer to pass the data to appropriate upper layer protocols. So it's common value like NCP, TCP, and UDP have 17. So source IP address. So we all know that the source will be the 32-bit of represents of this the source of the message, or and if we have a source, we have the destination. So the destination of 32-bit value presents the destination IP address, the packet. So the destination IP address is unicast, multicast, and broadcast address. So the next one, we have a router packet forwarding. So we have a packet forwarding. First, we have directly connected to router routes. Directly connected to routes is when its IP address is active, so it's the router interface connected to a different network of segments. So the remote route, so is the routes come from remote network connected other routers. These networks can be manually. So default route, so host router also is default. At last resort, no other route to design networks of routing tables. So you have a router is a computer. So router is a computer means it's a types of infrastructures available. In fact, Cisco routers design address needs to many different types of business networks. So we have a branch, one, and service provider. So branch is small business. So one is a large business. And service provider is service providers include Cisco SIR, Cisco CRS3, carrier routing of 7600 series of routers. So we have a default gateway host. So default gateways communicate over the network, so configure to correct IP address information. So default gateway for host gateway configure in local address. So the default gateway is only used for hosts who want to send a packet to the device or another network. So default gateway address is generally the router. So interface address attached in a local network. So local network of the host, IP address of the host device, and router interface address be in the same network. So this is all about in chapter 6 summary, and this all, and thank you.